Welcome guys, in this new tutorial of Blender and Geometry Nodes. In this video I'm going to show you how to make this useful asset about paillette. You're going to be able to adjust parameters, manage the rotation and define the material on the side A and on the side B. So let's get started. I'm working on Blender version 4.1.1 and to be able to start with this tutorial I'm going to create a simple mesh like a plane with a Shift A plane. We can set the global image for the world environment. So I'm going here in the world properties, click on the color, select environment texture, click open. I'm going to choose an HDR image for this and we can click here for the preview of the material. So the idea behind this is to create paillette on whatever surface you need. So select the object, go to the plus, general and geometry nodes. Click new to create a new geometry nodes. The idea behind is to make a simple grid allowing you to move some vertices a little bit to create a sort of checker texture. Next we are going to move these grid vertices on a surface and then we are going to instantiate some circles, adding some features like rotation. So first of all we need to define the grid. So I can press F3 grid and I can use this surface. We can export the resolution of one axis, for example the Y. We can rename this attribute in resolution, and to better manage this single value in the other axis we are going to use a ratio between the resolution of one axis with the other. So we can use a multiply mathematical function before going in the other axis and link this value in our group input and rename it in ratio. It's a float value, single value, from not 0 but 0.001, because next we are going to use a divide mathematical operation, and I remember you avoid dividing 1 by 0. Enable the snap tool if you need, and now we can increase a little bit the resolution like 100 and the ratio of 1. Press Shift Z and you can see this grid. I press 7 and because I want to instantiate some circles like the paillette, maybe I want to move this paillette making an alternative texture like this, for example. So for this reason I need to move these rows, okay, to the left or to the right or the opposite. So taking these rows here and moving them up or down to make a different kind of pattern. So we can select all these nodes, Ctrl J F2, grid definition. Now we want to shift this column a little bit by what? By the half of the distance between this point and this point. So we can start to add a set position, and to better see this result I'm going to enable the attribute text. This is very useful, thanks Blender team, to see whatever information on whatever domain you need. So in this case, if I add here an index field and press Shift, Ctrl and click, you can see all these values starting from 0, because we have indexes starting from 0, 1, 2, 3, etc. And after 100, I have the number 100 because I remember you, all the polygons starts with the 0 indexes order, so not from 1 but from 0. And the idea is to transform these rows, to select them and move them to the right or to the left on the x-axis. So to select only the correct vertices of this grid, we need to tweak a little bit this index. As you can see, we need to transform these indexes like this: 0, 1, 0, 1, 0, 1, 0, 1. In this way we can select only this row and move them to the right by a certain value. So to transform and select only these indexes, we can use the floor module and link what? The resolution of our group input. Why this resolution? Because if you divide each index by this resolution, you will get a value from 0 to the resolution itself, and over the resolution you will get again a value starting from 0, because the module of 100 with 100 gives us 0, and the result of 101 module 100 is 1, and so on. So with this module we can get 0, 1, 2, 3, so the same indexes of the first indexes you can see here, okay? And next, with all these 1, all these 2, all these 3, and so on, we can reuse the module, this time with 2, to get only 0 and 1 value. So I'm going to show you this. If I press Shift, Control and click, as you can see, we have now all 0 here, all 1 here, all 2, 3, and so on. And now, because we have uneven, even, uneven, we can reuse and duplicate this floor module using 2 and get this beautiful result here, all zeros here, all ones, zeros, 1, etc. And if I take these and ask if this equal to 1, I can use this result in the selection, and I can use this offset on the X to move only these vertices. By what? By a value that depends on the distance between this vertex and the next vertex. So as you can see, if I increase or decrease the ratio, the distance changes, and I need to move these values here by the half of this distance. So to calculate this distance, since we have the size of the grid equal to 1 meter, I can divide this 1 meter, so adding a math operation, I can divide 1 meter by what? The number of the vertices on the x-axis, so this axis. And if I divide 1 by this number of vertices, I get the correct distance between one vertex and the other. Next, I'm going to multiply this distance by 0.5 or divide by 2 is the same. And next, I'm going to use this in the combine XYZ only in the x-axis, because I want to offset only in the x direction, linking this to the offset. Drop this viewer and delete the annotation. This seems to work, but there is an issue, because if I set 10 and a ratio of 1 and zoom out a little bit, you can see we have this distribution of vertices between minus 0.5 and plus 0.5. So this distribution is not following these squares unit, and this is because in the grid we have 11 vertices. So to simulate the issue, I increase this value to 11 to have the vertices on the same point of the grid. And as you can see, with a ratio of 1, we don't have these shifted vertices on the half distance between these two vertices. As you can see, we have not 0.05 value, but less, and this is because here in the multiply we need to subtract the number of result of this multiplication by 1 before going in the divide operation. In this way we can use the Shift, Control and click here and here on the divide and get the correct 0.1 distance between these two vertices, and next divide by 2 or multiply by 0.5 to get the correct half of the distance. This is very important, otherwise with the high number of ratio you can see a little difference of shifting. Now I can drop this viewer, press H to collapse this, and this is the shift rows. But if I want to select the columns of this grid, I can easily select these nodes, press Ctrl Shift D to duplicate, maintaining the same linkage. And now if I click Ctrl Shift here and here with the index, what we need is to have 0, 0, 0, 0, 1, 1, 1, 1, 2, 2, 2, 2, and so on, to be able to have finally all these 0, all these 1, all these 0 again, to select only these particular vertices. And if you divide the index by the resolution itself, and now not the result of the multiplication between the result and the ratio, but the resolution itself, because the resolution is the number in this direction, so the y direction, I can get the correct integer value I need to pass it in the floored modulo math operation. So if I take this index and divide by the resolution itself, so the original resolution, what I get is these are numbers where I have 0 and I have the correct integer value when I have an integer factor of this resolution. So here we had 12 and here 24. If I select this index, as you can see, 0, 12, 24, 36, and if I divide all these numbers by this resolution, I get these. And from these numbers, I can get only the integer part using this floor modulo, but not selecting this, but the floor value, passing this value here. And if I select this with the Ctrl Shift pressed, you can see the correct number. So I drop this line for the offset to better see these values, and I will set the 0 for the manual value. As you can see, we have all these 0, then 1, 2, 3, 4, 5, etc. And now we can use the same result in the floor module by 2 to get all 0, 1, 0, 1, etc. And ask if this is equal to 1, we can select all these points inside this set position. Also in this case, I need to subtract by 1 the number of resolution, but not this resolution, this output, but the resolution itself, and link these in the offset, not using the x-axis, but the y-axis, and this is the shift columns. Now we can drop this viewer and we can add in our group input some check to enable the checker and or the alternative checker. So we can add a new input as a boolean, we can rename it in checker is a single value, and we can add here the group input asking if the checker is true, and if this is true we want the shifted geometry, otherwise we want the original geometry. In the same way we can duplicate these two nodes with the Shift D, press Alt P to go away from this section, press G to move inside this section, and do the same here, linking the original geometry or the shifted geometry. We can move this section a little bit down, this reroute value, and have another boolean attribute to decide if we want to shift the rows or the columns. And to do this, we can select this checker, click here and duplicate the item, renaming it in rotated checker. Also in this case it's a single value, and we can add another time a group input asking if we want the rotated geometry or not, and we can link the false condition and the true condition and the output inside our group node. In this way we can decide if we want a checker in this direction and if we want the rotated result. Now what we need is to move these vertices of this grid on our surface. So if I go in the edit mode, select all, press X to delete all these faces, and press Shift A to add a monkey, I need to show you this principle to work with the UV map. If I add a group input with the original geometry, so I press Shift Ctrl and click, this is the original geometry, and now I add a set position based by the name attribute of the face corner UV map, and this UV map is the original UV map of your geometry. You can see here in the data properties under the UV maps, this is the original, okay, UV map. If I link this to the position, you can see this result here. So all the vertices of this polygon has been moved in a single square one by one. So the UV map you can see inside this UV editing okay? This is the same result, but you can see a little difference because the system cannot move the edge in more than one position inside the 3D space. As you can see in the UV editing, one edge can be shared by more than one island here in the UV space. Why? Because there are seams. So to simulate the same seams effect, we need to go to geometry node and use the split edges here, getting the same result of the UV editing workspace. So now we need to see the same result with our grid, and if I press Ctrl Shift and click on this grid and another time on this grid, you can see this UV map that is not stored inside an attribute of this grid. Remember this. I hide for a moment this attribute text, and if I take these two elements and set the same position in this grid by this UV map, you can see the same position on a square 1 by 1. Now if I offset a little bit these and join these together, you see these, our grid 1 by 1, and the shifted position of all the vertices of our monkey that can have an enormous scale, always inside this square 1 by 1. So now the goal is to get attributes from this mesh, starting from the projection of the UV map of this mesh here. This means that if I want the original position of a single vertex of the monkey in the 3D space, not in the UV map space, but in the real space, we need to use the UV map of the grid in some point, use a sort of projection of this point on the UV map of the monkey, and get from that position the attribute we need, the position, the normal, or whatever attribute you need. And in this way, the system will be able to interpolate whatever attribute you need between all the vertices of the mesh. And this is very important because my grid can have millions of vertices, and I want to reposition these millions of vertices on a low poly monkey, for example. So I need to have all the interpolated position of the monkey in the 3D space to position all the millions of vertices of this grid. And to get this information, we can use in the geometry nodes a very powerful node called Sample UV Surface. We can increase a little bit the resolution of the grid, and now from this sample UV surface we can select the vector type, because we need to get from the mesh of our original geometry. So I'm linking the original geometry, so the monkey. I need to get what the position attribute, and this is the position of all the vertices of all the surface in the 3D space, not in the UV map space, not in this square 1 by 1. And to do this, I need to project what the sample UV, so the UV of the grid, on the UV map of my original geometry, so this square here, and this UV map. So to link the UV map of our mesh, we can easily take the name attribute of the original UV map and link this to the UV map. And to select this sample UV, we need the starting point and the starting UV map for the projection on the mesh. So we can use this link here and link this inside this sample UV, that is the original UV map of the grid. So this is the schema. Remember, the mesh you want to get the attribute you want based by its destination UV map and the source destination of our grid. From this output, you will get for all these points the value of the attribute, in this case of the position. But how can I say system will get the sample UV from the grid? Because here in this node I can't link the grid itself. You are right, but because this is a context input socket, so this depends on what is the flow the system will try to follow. So in my case, if I want to move the vertices of this grid in the original position of the monkey, I need to get this grid, and not this but the result of these shifted columns or rows vertices from this switch, and add a set position node linking this value to this position. And from this flow of nodes, the system will get from this mesh, so the grid, will get the sample UV attribute to use inside this sample UV surface. In this case, we have the UV map of the original grid. And even if I move the vertices inside this switch, I always have a UV map value inside the original vertices of this grid. Now if I press Shift, Ctrl and click, as you can see, we have this reposition of the grid. Now we have two issues to solve. One is this: not for all these vertices inside this grid I can get the correct attribute on this square by one based by this monkey. As you can see, we have empty space here. So instead of moving these vertices together with the other vertices that can have an attribute from the surface, we need to clean this grid before the operation of the sample UV surface. And to do this, we can easily use this technique. During this operation, we can add a delete geometry, link the result of the grid, link this to the geometry, Shift, Ctrl and click to see the result. You can see the delete geometry deletes all the points. But if I link the not result of this is valid here, I have the correct result on the mesh. If I press Shift and Ctrl, you can see the deleting operation on our grid for all the points that cannot reach the position attribute using these two source and destination UV map. In this way I can have a correct and clean geometry, and if I press Ctrl and Shift on this final set position, you can see the correct repositioning on this surface. And if I mute this delete operation, the system will set 0 for all the vertices of the grid that cannot get the correct position on the UV map of the monkey. Now that we have this clean workflow, we can select all these nodes, Ctrl J F2, delete points not on the UV map of geometry. And this was the first issue. The second issue is this: because we shifted some of these vertices, the values of the UV maps of the original grid are not the same now that the vertices are shifted. And I can show you this pressing Ctrl Shift click, decreasing the value of 10. Okay, and as you can see, we have a UV map here 1 by 1 and 1 by 1 because we have a grid mesh 1 by 1 meter that has a problem, because if I deselect the checker, I have a perfect square and colorized square 1 by 1 from 0 here to 1 here, with the correct and linear proportion and distribution of the values of a UV map. But if I enable this checker and for a moment I mute this link and increase with a very high number this offset, as you can see, we no longer have a correct distribution of the values from 0 to 1 in the space. Okay, we have a distortion of the values. Why? Because this information comes from the original position of the grid, and the system will inherit this information after these nodes. So we need to recalculate a new UV map after this shifting operation and use this UV map inside this sample UV surface node. So to recalculate this UV map is not so hard to do, because we can get this result of the grid, calculate the bounding box, and this is the final bounding box, and capture the information of the position of all our vertices of the grid based by a square 1 by 1, starting from the minimum value of this bounding box and the maximum value of this bounding box. So with this minimum and maximum, we can use a map range node with a vector type, it's obvious, from the minimum value of this bounding box and the maximum value of the bounding box. We want a value of a vector from 0 to a maximum vector of 1, so from 0 to 1. And if you separate this vector, you will get all the vectors inside this square one by one. So now here we need to link what? The current position of our grid and store with a capture attribute here in the middle what the vector for each face corner, because the UV map works better in the face corner because it allows you to have an interpolation between all the 4 or multiple vertices of the same faces to correctly distribute the color, the texture, or whatever material you want inside this face. And we can link the output of this map range inside. And now if I press Ctrl Shift on this geometry, but not linking the original UV map of the grid here, but this value, you can see the difference. Okay, you can see the difference because now here we have a perfect square from 0 to 1 with the correct distribution of the color inside our grid. And we needed to select this map range inside this sample UV surface to get the position socket and whatever attribute you need. Now we can select all these nodes, Ctrl J F2, generate new UV map of the grid, and we can restore the link of this shifting operation. Now we can drop this viewer and see the result, increasing the resolution like 62. Now, as you can see, in the final surface we have some strange edges here in the 0 point, and if I press Shift Ctrl and click on this geometry and press Shift Z to see the result here and link the output of this delete geometry inside this set position, you can see we have some bad values on some vertices. I don't know why we have this problem in Blender, because the isValid should be the correct output socket to define what vertices I need to leave inside the geometry and what not. So to solve this problem, if I enable the surface, you can see all these edges are connected to 0 faces. So we can clean this geometry another time, adding here another delete geometry. In this case, we can select the edge domain and we can add an edge neighbors node. And if the face count is equal to 0 for these edges, so the face count is used to calculate the number of faces connected to the same edge. And if we have this situation and press Ctrl Shift and click, you can see the correct cleaning of the surface. I can show you here in this join geometry, linking this output of delete geometry here. And as you can see, now we have the correct surface. I can drop this viewer and now we have the correct surface in the 3D space. Now maybe you want to preserve the original geometry, so we can add a simple input attribute like the hide original geo. It's a boolean type, a single value. We can add a group input node asking if this is true, and if this is true we only want to have our paillette surface, otherwise we want the original with a join geometry with this paillette surface and link this to the false and link this to the geometry. In this way I can have the original surface and the paillette surface. I don't know if you can see these here. We will see better next. We can select all these nodes, Ctrl J F2, hide original geometry, and if I enable or disable you can see the difference. Now we can start to make the instances of our circles, and to do this we need to add with F3 instance on point this object, and we need to have a circle curve. If I link these to the instances, this is the result. It's a bad result, it's obvious, because we need to export in the group input what the radius of our circle. So for example, we can set a single value here, this is a float value. We can move these a little bit up and set the 0.03, for example, to have this result. Before instantiating it in this node, we need to fill the curve to have a physical shape, and this is the result. I can hide for a moment the original geometry, and I saw in some images that some paillette can have a little hole in the center. So for this reason, I can duplicate this curve circle, and using a group input new attribute, we can add a whole boolean attribute as a single value. And if this is true, we need to link inside this fill curve both of these curved circle with a radius having a proportion of the radius between the radius of the big curve circle and the little curve circle, because we want to have a hole inside. So we can get this radius, multiply by a value of 0.3 maybe, link this to the radius of the second curve circle, join them together, and inside this switch choose the correct final circle we need. So if we want the hole, we need to have this geometry, otherwise we want only one circle. And after this switch, we can select this output and apply the fill curve. We can test it. If I select this, as you can see, we have a hole inside all the circles. So why this? Because I remember you, if you press Ctrl Shift on this curved circle and join two curves on the same x and y plane, and you apply a fill curve, the system will join or apply a sort of a Boolean operation between all the curves on the same plane, group it by this group ID. I don't mind this group ID in this case, because we have only two curves, and the result is this. Now we can select all these nodes, Ctrl J, create paillette. Now we need to rotate all these circles based by the rotation of our surface, and we can also increase this value like 120, like this. And to align in a correct way these circles, we need to get the normal based by the same principle used in the sample UV surface. So we can select all these three elements, press Ctrl Shift and D to duplicate and move up a little bit, press Alt P to exit from this section. We can link directly this generated new UV map inside this sample UV, and instead of getting the position, we need to get the normal information of all the surface of the monkey. So after the instancing, we need to rotate instances, and we can use the align Euler to vector twice, and we can use only one time from the version 4.2 of Blender, because in the next version there is a node that includes two of these align Euler to vector in only one node. So because we have the 4.1.1, we need to use these twice. So first of all, we need to rotate each of these circle, moving the z direction, so to align the z direction of each of the circle. So I'm going to select z in this align Euler to vector. To what vector? To the vector of the normal got from this sample UV surface, so the monkey, and I'm going to link this value here. And if I link these directly in the rotation and then I link these instances here, you can see the correct rotation of the circles, but we have a problem, because next we need to move the circles based by an axis to rotate down or up. We need a second alignment to maintain the correct z direction on the normal of the surface, and a second axis down on the negative z direction of the 3D space as much as possible. So to do this, we need to inform the system we want to maintain the original z-axis, so don't touch the z-axis because we set previously here in this node, and use this result rotation to align another axis. In this case I can choose the X or the Y, it's the same. I'm going to choose the X and try to align the X in the negative direction of the Z, because I want to have the Z in this direction, but I want to have for all the circles the X through the negative Z direction as much as possible. Okay, in this case, from this perspective, this is the Z and this will be the X direction. For this, the Z is here and the X in this direction. Okay, and why this? Because next we are going to use the y-axis, the local y-axis, to rotate all these circles, because in the real environment you cannot have the two circles overlapped to each other. We need to rotate a little bit, or you need to rotate in a little random way, or you need to flip the rotation of all these circles to see not the side A of the paillette but the side B. And now we can link this rotation. You don't see the difference, but believe me, it works like a charm. So we can use these, we can move these nodes here, select them, Ctrl J F2, first alignment. And if I decided to not hide the original geometry, maybe we want to add a little offset between the paillette and the surface to not have an overlapping effect. And to have a better surface, I can select the monkey and add a subdivision surface like this and move these before the geometry nodes and set 2 to have this result. Now, before adding the offset, we can assign a material on our paillette, so we can set a material, set material, and link these to the group input, and we can add a new material called geometry, the original geometry, that is white. Add another material that is the paillette and decrease this color, go in the geometry node and select these from the menu. So in this way we can see the original geometry color and the paillette color. Now that we have the normal information from this sample UV surface node, we can go here inside this set position, and where we have the position to apply on our vertices of the grid, we can add the vector of the normal of the surface scaled by a custom value. So we can take this normal, scale by a value that we can export in the group input, and set offset here, drag up near the radius, set it as a single value, minimum of 0, and this is a distance. This way we can set 0.02 meter, for example, and link this scale in this add vector and link this add vector result inside this position. And as you can see, the result is better. We can select all these nodes, Ctrl J F2, offset. We can drop all these unused node, and before to the set position node, we can save the current UV map of the grid removed on the surface of the monkey. So we can move these a little bit, move these here, and use this delete geometry to store a name attribute, linking this inside the set position, because here we want to save the vector of the new UV map. So the vector of this generated new UV map of the grid, or if you prefer and you want to use the interpolation system from the monkey, we can reuse a new duplication of these nodes, pressing Alt P to exit and linking the same sample UV map. It's obvious for our grid, not getting the position this time, but getting the same UV map, the same original UV map values of the monkey, of the mesh of the monkey here in the value. So in this way we can save this value inside each point, not each face corner of our grid before to set the correct position in the space. And we can set here a value of v underscore uv, select all these nodes, Ctrl J F2, save uv map in the paillette. Now to see a preview of the result, we can go in the shading menu and we can import an image like the logo of Blender, like this, link this to the base color, and to see the result of this paillette we need to have a vector coordinate system. So we can add an attribute we can get from the instance here and not the geometry, because in the geometry nodes here in this point, in this output, we have instances and not real geometry. So the information of these UV is inherited from the points to the instances. So inside this shading we can set here the v underscore uv and link this vector here in the vector of the image, and we can start to see the result of our image. We can set the full metallic object and 0.1 for the roughness, and this is the first preview of the paillette. Now to see in a more simple object, we can delete the monkey. We can add, for example, a cylinder, and we can disable the surface subdivision, increasing the number of vertices like this. We can go in the shading editor and take this attribute and add a map vector to scale it down, and we can scale it a little bit like this, for example, and move the location on the 3 axes as you need. And because we have a PNG file, we can transform the alpha of this in white. So as you can see, if I press Ctrl Shift and click here on the alpha, we can invert this color to get this result here, and we can add with a mix node this value with this value, setting these to 1 and link these to the base color. I'm wrong here, we need to set the add type to add the colors of the original image with this inverted alpha color of the image. Now to see the correct paillette, maybe we need to rotate the checker, so to have the shifted columns of the circles in this direction and not in the horizontal direction. We can increase the resolution a little bit and set 1, for example, for the ratio. And now we need to rotate these circles because this result is very ugly. So going back in the geometry nodes, we can go here between the first alignment and the set material, and we can add a piece of workflow, adding another rotate instances, and here we can add a combine XYZ and link these to a rotation node to convert these Euler values in a rotation and compatible values, linking these to the rotation. And now if I rotate these on the y-axis, as you can see, the correct rotation of all these circles in the same way, and this thanks to this second align Euler to vector node. If I mute this node, as you can see, we can have a different rotation because we have a different y-axis for these circles on the surface, as you can see here and here. So I am going to re-enable these. And now remember, this is not degrees if you link something from the external part, so we need to add here a radiant node because we like play with degrees and not radians. So we can link these in the group input and rename it in rotation. We can move these before the material. This rotation is a float value and a subtype of an angle. We can leave negative number because maybe you want to continuously rotate these circles, and I will set this as a single value. now that I have here all these degrees, as you can see, the system is very slow, and this is because this value is not correctly converted to these radians, because from here the system have here the degrees, but here is converting degrees in degrees to convert these in radians. So we can drop these and link directly this rotation that here is in degrees, but from this output we don't have degrees but radians. Okay, the system will automatically convert these in radians, as you can see with your eyes, minus 0.174, etc. So we can leave these, and now you can see a better result of the circles, but we can do more, adding a random rotation on the other local axis. Remember, local space, so local axis of the circles, and to do this we can add a random value, and we can set here a vector from a minimum value of a negative angles or negative radians and the same positive value. So in this way I can move in one direction or the other direction from the local axis of the circles. And to do this we need to have a new group input node, adding another float value called random rotation, and we can limit this rotation between 0 and 1. So 0 is 0 and 1 is a maximum rotation of 90 degrees in one direction or the negative 90 degrees of rotation. So in this case we can select a single value, a minimum from 0 and maximum of 1, and link this random rotation in a map range node where the 0 value is equal to 0 degrees and the maximum of 1 is a maximum of 90 degrees. And from this output we can multiply this value by -1 to have the minimum value of the random values and the positive value for the maximum random value. In this way I can have from this a value of 0.5, so 45 degrees, so a range of random value between -45 degrees and plus 45 degrees. But because we are going to use radians and not degrees, we need to move this a little bit and link this result to a radiant mathematical operation before linking this to the random value. Now, because the y-axis is already used inside this combine xyz, we need to separate the components of this vector and link the x and the z in the correct socket, or use the same x. It's the same because this random value is the same. So now that I'm thinking this, we can easily use a float value instead of a vector, linking these multiplied here and these, and not using the separate vector, linking only this value for both of these two sockets. And in this way I can easily increase a little bit this value by 0.07, for example, to have a little bit of rotation, random rotation on the circles, leaving the correct principal rotation on the y-axis. But there are some cases in which you want to have the first rotation not on the y but on the x, so you don't want this big rotation in this direction, so following this axis, this horizontal axis, but you maybe want to follow this axis, so not the z, you can be confused, but not this axis but this axis on these faces. And we can add a simple check to add this flipped operation. I can add here a socket like the axis rotated x and y. This is a Boolean operation, single value, and we can select this in a switch, setting here a vector. And if I want a rotated vector, I don't want to use this combine, but I want to use a combine using the x and not the y first rotation. And next I want the random rotation on the other axis. So this is the true and this is the false condition, and this output linked here. So in this case, if I click here, you can see the opposite rotation of these circles, and it's obvious you need to tweak the resolution and ratio to have the correct distribution of the paillette. So in this case, maybe I need to decrease the resolution because we want to have more space in a vertical direction, and increase the ratio like this, setting 4, for example, and you can see a similar effect like the scales of a snake. And if I uncheck the checker, as you can see, the same result, but in this direction for the principal rotation. We can select all these nodes, Ctrl J F2, rotation, custom rotation, and finally we can add another piece of a workflow to select not only all the surface of my geometry, but only a portion of a geometry. So to do this, we can enter in the edit mode of this cylinder, press Ctrl R to subdivide these a little bit like this. I disable for a moment the geometry nodes, and what I can do is to select all these vertices, go to in the vertex group, add a vertex group, assign this vertex on this vertex group, and here when I use the original geometry inside the offset of the grid or the delete points of the grid, or to select the UV map, we can use a different original geometry, so a masked geometry, a selected part of the geometry. So to do this, we can add other two input, so duplicating these and rename it in mask. This is a single value, boolean. We can add a group input inside our workflow and ask if the mask is on, and then we can use the geometry and delete the geometry that has a value of this assigned group less than 1 as the weight. So we can add the second attribute, input, and this is the vertex group. This is a string value because we need to set the name of the vertex group we need to use. And now we can add an attribute, an attribute name like this, link this vertex group here. The value is a float type, and if the attribute is less than 1 as the weight, we need to delete this geometry, and if this mask is enabled, we want this result, otherwise we want the original geometry. So in this way we can move this a little bit like this, Ctrl H to hide the unused attributes, select all these nodes, Ctrl J F2, masking. Now we can link this output inside this sample UV surface, inside this sample UV surface, and delete this group input, and also here in this save UV map node. So I'm going to click here and create a reroute with the shift right button. I'm going to select one of these group input, go to select grouped type to select all the group input of all the workflow, press Ctrl H1 and twice to hide all the unused socket. And now if I exit from the edit mode, enable the geometry nodes, I can rename in paillette and check this mask and set here the group, so the name of the vertex group I created. As you can see, we have the paillette effect only on this part of the mesh, and if I want to manipulate this object in the side A and in the side B, we can go in the shading editor. For example, I can add here a hue, saturation and value node, setting 0.54 for example. Duplicate this principal BSDF to have a different material for the side B, add a mix shader here, link the first material, link the second material, and link these to the final material, link these result in the base color of the second side, and to set the correct factor here we need to add the geometry node and link the back facing here. So the back facing means that you have 0 for one side of a face and 1 for the other side of the face, and this will let you have the opposite material to the other side. So if I increase this rotation on these circles, you can see the other part of the mesh. Why I don't see anything? Oh yes, I linked the result of the color in the hue and modified the saturation. No, it's wrong. I need to link the color in the color, and I wanted to change the hue and not the saturation, so I need to drop this link and set 1 for the hue and 1 for the saturation, for example. And as you can see now, if I rechange this rotation, you can see the transaction between the two faces of our texture. So here you are able to manage the scale, the location and the rotation of the UV. And a little tip, if you don't have a geometry like this, but a geometry like a plane, for example, and for this I will delete this face and create a single plane like this, pressing A, and remember to unwrap the surface. You cannot see anything because I have the mask selected, so I disable this mask, and as you can see we have this result. I'm going to manage a little bit the resolution like this, perfect. And if you want to manipulate the UV of the original geometry, leaving the own coordinate system for this paillette texture, for example, going here, if I take this face and I move, as you can see, we lost part of the UV map and we have a strange shifting of the texture. Or if I scale these up and down, we always have the proportional scaling of the result of the sample UV surface node in the geometry node. We can easily use an empty object, so I can go out from the edit mode, press Shift A, add an empty plane and position it, for example, here in this point of the object. And next we can go inside the shading editor, and instead of using this attribute we can use the coordinate system, and in this way we can select from this eyedropper this empty and use the object vector inside this mapping, setting 0 and mapping these to 1. Okay, and now as you can see we can manipulate this coordinate system independently from the UV of the object. So as you can see, the image stays in the right place. I can set 0.5 to have only one image, and I'm free to go in the edit mode, hide the original geometry, press Ctrl R and divide it twice, for example, select only this edge here, press G and move up a little bit and re-enable, for example, the subdivision, and this is the final result. I can increase the subdivision another time, and that's it. I want to show you a last part of the tutorial about this rotation, because it can let you do some stuff in the animation and style like the intro of this tutorial. So instead of using this rotation from this workflow, I'm going to use a different approach, a procedural approach, using, for example, the scene time information, and we can move this edge a little bit up, and remember to re-unwrap the surface after the transformation. And now if I link these seconds directly in the rotation, as you can see, if I press play, all the circles are going to rotate with the same speed, but maybe I want to add some particular effect like a noise texture, and for this reason I can add these to the add node and link these to this result. You can manipulate the scale of the noise texture to manipulate the pattern, and you can multiply this value before adding these to decrease the speed of the rotation. Or for example, another type of animation is this, so I can take the scene information, I can take the current position in the space of each circle, separate the components, take the Z and use it in a map range, when for the minimum and the maximum we have our result of output here. We can use in a mix value like this, using this result as the factor between -10 and I don't know, 100 degrees maybe, and using the seconds, adding a constant value for the minimum and the maximum. We can set our range of values in height when we want a gradient of a transition between a rotation and another rotation. So if I link these to this rotation, we can see what happens. If I go to the first frame, you can see the rotation between one side and the other side of the faces of these circles. But maybe we have too much rotation here. We can set a little bit of rotation like these. Okay, and you can see if I press play, you can see the correct transition between one value and the other value. But maybe you want to start to a Z value below 1, and to do this we need to subtract from these seconds, subtract a value before going in the mean and in these adding value. In this way, in the first frame, we can manipulate the range on the height where we want, okay, as you can see. And if I take this object and rotate on the x-axis like this, we can see better the result, because here we can move the transition where we want to start. And if I press play, you can see the transition from one side to another side. Now I'm using the empty object, so remember to rotate this object too, or to parent this object to this object if you want the same result. So for example, if I take these and rotate by these degrees and press with the shift this Ctrl P object, now if I rotate this piece, you can see the same behavior on the surface. And remember, the local z-axis of this object now is changed. Okay, so remember this factor. So in this way I can choose the start and the end point of the transition. I can increase or decrease the range of the gradient from this minimum and this maximum value, so the space between these two values. And this is a second tip you can use in your workflow. If you don't need to use this, but you need only a constant value, use this rotation socket of the group input. And that's it. Thank you guys for watching this video. I hope you learned something from it. You can always download this project from my Gumdrop page, and inside you will find the file of my intro video. If you like my work, please subscribe to my channel, and don't forget to check the bell icon to get all the notification of my new videos. See you to the next tutorial. Bye!